Hello. In this video, we are going to show how we can use Ansible to build a pacemaker cluster for an SAP HANA scale-up installation. It extends what's been already explained in the blog series Automating Your SAP HANA and S/4HANA Deployments using Ansible. In this case, we are going to use the Red Hat Ansible Automation Platform, or Red Hat Ansible Tower. So if we take a look at it, we can see we have dashboards with the number of hosts that are connected to here, the inventories that we have, and the different projects for the different playbooks that we are going to use. So if we go into the inventories, we're going to see the hosts. We have a group called SAP hosts. Okay, and here we have some common variables for the hosts that we are going to use. So for the playbooks that are going to be run on those hosts. So for example, with where the software for the SAP host agent and SAP HANA is, the passwords that we're going to use. We can also use secrets, Ansible secrets for the passwords, so we don't see them. So we won't see them here in clear text. So the IPs that we are going to use for the pacemaker cluster, etc. So all the general variables that are common to both of the hosts that we are going to use. If we go in hosts, we can see the two virtual machines that we have created and that at the moment have nothing installed but the operating system, the RHEL operating system. And here we have the specific variables for each of those hosts. So in order to create the partitions and file systems to install SAP HANA, also the path to where the software is, more passwords, the HANA instance number, etc. Now, first of all, let's take a look at the operating system level in those virtual machines to make sure that there's nothing created apart from the installation of the operating system. We have a Bastion server where we will be running the Ansible playbooks, or the tower will be running the Ansible playbooks on the two HANA servers, and from there we can connect to the actual servers where we are going to do the installation of HANA. So here's one of the servers, and if we look at the file systems that we have at the moment, as we can see, it's only the file systems that are created when the operating system is installed, and apart from that, we have mounted an NFS, a file system with the software that we're going to use for the installation. If we connect to the other server, we will see the same. Okay, so those are basically the file systems. And now we'll go back to the Red Hat Ansible Automation Platform to take a look at the playbooks, templates, etc. that we have created. So for each one of the playbooks that we want to use, we have to create a project. We can see them here. For example, if we go into the SAP HANA deployment, we can see the type of project that it is, and that it is it's taking the actual playbooks from a Git repository, a GitHub repository. Here's the URL for it and the branch that we are going to use. Okay, so also for each one of these projects, we need to create a template. You can see them here, that we have a template for each one of the playbooks that we are going to execute. And then we have some playbooks with the actual complete workflow of what we are going to do. Namely this one, the SAP HANA High Availability End-to-End Deployment is the one we will be using today. So if we go here, we can see the workflow visualizer to see the different steps that it has. If we do a bit of zoom in, we'll be able to see the different steps that we said. So the first step would be to install or to register the host to the repositories, the RHEL repositories that will allow to download the software in order to run performantly the SAP HANA. So this software will install all the SAP nodes with recommendations for HANA to be run on RHEL. Then the SAP storage step will partition the disks and create the file systems for the installation of the HANA. Then this one will install the SAP host agent. And then we have the SAP preconfigure and the SAP HANA preconfigure. There are two of the SAP system roles for RHEL, for Red Hat Enterprise Linux, that come with the subscriptions for SAP. So we have two flavors. We have the RHEL for SAP solutions and RHEL for SAP applications. So both come out of the box with the system roles. And what they do is what I just mentioned. They install all the SAP nodes that are the prerequisites to run SAP HANA. If we were to install an SAP NetWeaver-based application like an S4 HANA, we would use also another SAP system roles that is called SAP NetWeaver preconfigure with a note specifically to any NetWeaver-based application. Then we have the playbook to install or deploy the SAP HANA on both servers, and then to configure the SAP HANA system replication, and finally, the one that will build the pacemaker cluster. So let's just trigger this workflow. When we do it, we will see the execution of each one of the steps. So if we go into details, we'll start seeing the logs just as we would see them if we executed the playbooks at operating system level. So if we go into details, we can already start seeing all the tasks that are being executed. So since you've followed the bug series and you already know the first part of this deployment until the SAP HANA is deployed, we will just jump to the, or we will wait till the SAP HANA is deployed on both servers, and we'll see what happens with the HANA system replication playbook and the pacemaker cluster creation playbook. Well, we can see now that the SAP HANA has been deployed already, and the HANA system replication is being configured. Now, we'll look at the logs. We can see that everything, all the tasks have been completed. Right, and if we log on to the servers at operating system levels, we will be able to see the HANA databases up and running. So we can see first of all that the installation user or the administrator user for the database has been created. We log on with it. It's there, and if we check the processes of the HANA database, we will be able to see them there. So the installation of HANA is completed at the moment. If we look, we can see that the HANA system replication has been configured as well. If we look at the logs, we can see that all the tasks have been completed successfully. So taking the backup from the primary, then exchanging the keys, SSH keys and the certificates, then enabling the system replication in the primary and registering the system replication on the secondary, so registering the secondary to the primary node. Everything has finished successfully. And if we go back to the terminal, to the operating system, we can check that the system replication is actually enabled. Just run the Python scripts to check the status of the replication. Okay, and we can actually see that this is the primary node, the primary side as well of the replication that is replicating the two DBs, so the system DB and the tenant DB is replicating to the secondary server. The mode is synchronous and the replication status is active. And if we go to the other side and we run the same script, we can see also that is currently configured from that side. Here we can see that it's registered correctly to the primary side and the mode is sync. So finally, we can see that the last playbook, the last step for the creation of the pacemaker cluster has finished. So in total, the whole workflow has taken only 30 minutes, and that's to do an end-to-end deployment of a scale-up HANA installation with system replication and with a pacemaker cluster created with just one click. If we go into the details, into the logs of the last playbook, we can see that everything has been executed successfully as well. Okay, all the tasks of the playbook have been completed, and now we'll go back to the servers and check the actual cluster. So let's go, for example, to the secondary server, and we'll just check the status of the cluster. See all the resources and everything that's been created. Okay, so we have here all the information. It's using Coruscant, which is a data center that is the primary. So now it's the secondary server, the HANA 2 is the cluster or the node to which we are connected. We have the two nodes configured, all the resources are configured, everything is online, so both nodes are online. And the list of resources of the SAP HANA topology, that's the one that gives all the information of how the SAP HANA scale up has been configured. And then we have the actual resources for the database, so the SAP HANA RHE, that are controlling the system replication. And we have a virtual IP that will be failed over in case of any issues in one of the nodes. The virtual IP will be failed over so that the applications or the users will be able to connect to the other node seamlessly if anything happens to the current primary node. And here we have all the attributes and how Pacemaker internally stores all the information of the attributes. We can see the type of replication that is synchronous, as we had seen with when we executed the Python scripts with the HANA databases. We can see who's the primary and who's the secondary. So in Pacemaker language or in Pacemaker terminology is promoted and demoted. We can see who's on the primary data center, the secondary data center, the status of the replication, that is SOK. And yeah, all the information, like the version of the database, which is a HANA 2 revision 46, and who's the master node, worker node. So all kinds of information are here. We can also check that the right constraints have been created with the Pacemaker cluster. So those are the constraints that are needed in order for the Pacemaker cluster for HANA to work properly. So the SAP HANA topology resource must be loaded or started prior to the SAP HANA resources, to the system replication resources, and then the virtual IP must always be where the primary of the replication is, so that the SAP application or the users will know to which node to connect. We can also do a test and force a manual failover of the cluster. So what we can do is move a resource to the other node, for example, the virtual IP, and see that the primary of the database is actually failing over automatically to that node. So that's the behavior that we would expect if there's a failure on the node where the resources are currently running. So at the moment, they are running on primary, and the virtual IP are running on HANA 1, as we saw. Let's check it again. Yes, as we can see, virtual IP is a node HANA 1 and the master of the replication as well. So let's just do a manual move and force the failover. Let's say that we want to move it to HANA 2. And let's watch what happens. You can see that the virtual IP has already been moved to HANA 2. Now HANA 2 is being promoted, so becoming the primary of the system replication. And finally, it has been promoted HANA 2, so now it's the primary of the replication and it has a virtual IP. So yes, that's how easily we can deploy and perform the creation of SAP HANA scale-up installation with HANA system replication and with the creation of pacemaker cluster for it. Thank you for watching.